This video is an introduction to the MarkTag software. Topics that we'll be covering in this session are the description of the window displays, selecting tag IDs for viewing, verifying data from a tag, and viewing a georeferenced map of a project site. To start the program, click on the MarkTags icon of the desktop. The very first step in viewing or processing a data file is to first open up a project database. So under the File menu option, Project Database File, we'll open up our example project database. This is the main source for the program in terms of obtaining the tag list for a project. Here we have a total of 952 tags that were released for this project. Normally, for viewing a data file or processing any kind of data file, you don't necessarily have to look for each tag in your entire list. So this dialog box has a number of options for selecting a subset from your tag list. So we're going to select release number 6 under the tag selection options. You hit the select button, and in the main list box are all the tags that were released for that time period. So then, to have the program use this subset, select the use and marking option, which they all have an X now next to it, and say OK. In doing so, on the main toolbar, there is a select period control, which now displays all of the tags that we have designated for release number 6. The next step is in the period histogram window in the lower left corner. Under the display options, we want to set a range for the periods that we want to view. So for this release number, we're going to look for all periods between 4900 and 7100. Once we set the range, now we see these vertical red lines in the period histogram. If we zoom in, these are all the indicators of the periods from the tag list. So if you notice in the lower left corner of this window, the number changes. That's the period position as we move the cursor across the window. So for example, here at 5903 is one of our tags in our list. In the lower right corner is a subcode histogram. And this has the option of viewing the lower subcodes, or the upper subcodes, or the entire subcode from 1 to 31. This will be explained when we read in a data file and look an actual tag. So let's open up a data file now. So under File, Raw Detection File, Open. Let's open up the first one we have here. For the data collection system, normally files are saved on an hourly basis. And when you open up a file in MarkTags, it displays the entire contents of the data file. So we here have an hourly file. And when you read in a file, it could be from a multiple hydrophone system. So on the main toolbar, there's a select hydrophone control, which is updated every time you read in a data file. So we see here that there are 4 hydrophones that were stored to this data file. And using this control, we can select to view the data coming from each hydrophone. So this is hydrophone 1, hydrophone 2, 3, and 4. When you read in a data file, normally the setting is set to view data from all hydrophones for the entire file. Now let's take a minute here to describe what is being displayed here. Each white symbol here, and we can zoom in on a section of the display. Each white symbol represents an acoustic signal that was recorded by the data collection system. Now, not every signal is coming from an acoustic tag. Depending on the project site, there could be sources of noise, for example, electrical pumps or mechanical machinery that can cause noise to be introduced through the cables that connect the hydrophone to the acoustic tag receiver. There also can be noises that are caused by environmental conditions. An example right here is this is a typical example of a noise coming from the motor of a boat as it passed through the hydrophone array. So all this here, again, would not be coming from an acoustic tag. There are various ways of displaying the data. So on the main toolbar, there is a Display Options button. And here we're currently set for mark state. And if you click the Edit Colors, this tells you that the symbol of the signal is based on its processing state. So right now, we have not done any processing to this data file, so all the signals are white, indicating that we have not assigned a tag ID to any of the signals. Once you start processing the data files, the color scheme will change for each signal. This will be explained further under the Processing Basics video for MarkTags. The other option for viewing the data is based on hydrophone color. So you select hydrophone, say OK. So now each signal is displayed based on which hydrophone it was collected on. When you read in our project database, in addition to the tag information, MarkTags also obtains the information on the hydrophone, and in this case, what color scheme was assigned to each hydrophone, which is configurable. So here, if we go through our hydrophone list again, hydrophone H1 is in purple, and here we have on our color bar window the color for H1, and H2, H3, and hydrophone 4. Going back to display options, there's another feature for viewing the signals based on voltage. So here we see our color bar window showing us the various colors for the ranges of the voltage values for that color. And so you can zoom in and see the different color schemes and how strong the voltage was for that signal. So we have signals. So how do we tell that a signal is coming from an acoustic tag? Well, in the period histogram, this display calculates the frequency distribution for a period or the transmit time for a tag. So if we zoom in on this one section here, we see that we get a strong line of data here at this particular period position. And if we move our cursor, we see here that it's period 6420, which means that pretty good indication that a tag that was pinging at 6.420 seconds is in this data file. since we have a good, strong distribution at that point. So let's go up and under the select period, see if we can find a value that's close to that. That's from an actual tag. And here we have a 6421. So now we've set the scale here for viewing data from that tag. Now a little description on how we know that these signals are coming from an acoustic signal or a tag. In HDI acoustic tags, the period or transmission time is very precise. So when a tag basically pings, it waits for a specified interval and then pings again. So in this case, this tag ID would be 6421, which is basically the tag is pinging every 6.421 seconds. And so since we know precisely when the next transmission will be, when we display the data, we set the vertical scale of the main display to view precisely that transmission time. And if it's set for the correct period for that tag, then all the signals for that tag will be lined up horizontally, since it is set for the proper period scale. If we have the vertical scale set for a different tag, we still see signals from another tag, but they will not be lined up horizontally, but in a diagonal fashion, since it's not set to the vertical scale that we currently have it set for. So in this case here, every time we change the tag ID here, it automatically sets the vertical scale of the main display to view signals at that specific transmission time. And this is why over here, if we zoom in, we see two horizontal sets of signals. So this is a pretty good indication that because we have our vertical scale set for that specific transmission time, we're seeing the signals line up horizontally. So this would indeed be the signals coming from tag 6421. Now the other line of data here is that we've got a double pulse tag, which basically means that it transmits its primary pulse at the 6421 milliseconds rate. Right after that, at a precisely specified time, it transmits the secondary pulse. And that's why we call this a double pulse tag, since it's transmitting two transmissions, basically. And we have a option here under Query Double Pulse for the cursor control, that if you encircle the primary and secondary signal, it updates the subcode histogram in the same fashion, where it's calculating the difference in time between the primary and secondary signals and tabulating the frequency distribution, where we see here that, oh, this looks like the difference between primary and secondary fits within our subcode 19 distance. And again, over here, we have a 6421 with a subcode of 19. So this is another indication that these two sets of signals are coming from that specific tag. Zoom out here. The main display, as I've said, is on the vertical scales in time, but also the horizontal scales in time as well. So you can imagine that the top part of the display is the hydrophone, and then the further down we go in the window, the further away you are from the hydrophone. But it's not a distance measurement, it's a time measurement in terms. So we both have a vertical scale in time and a horizontal scale in time. A tool that we have called the bookmark tool, when you move it within the main display, and the status bar in the lower right corner, it gives you the time for that specific position that the bookmark is being moved. So if we move it, you'll notice that the time is changing. And so we see that there's a little bit of signal here from the tag. So it started at 8:32 as far as being detected within the hydrophone array. Then it got stronger at 8:42 and then continue on until the end of the data file. So let's select another tag from our list. Instead of viewing and zooming in on various sections of the period histogram, we can also just scroll through our tag list and see if we can identify signals for that specific tag. So the next one is 6435. And as we covered in the diagram here, you'll still see signals from other tags, but because it's not lining up horizontally in terms of the vertical scale set for that specific period, it will be uncorrelated, as we call it. So here is the situation where we've set the vertical scale for tag 6435. So there, that these signals are not correlated with this specific period. So we would not mark or view these signals coming from that tag. So let's look at another tag in the list. And as you have this control, have focus, which is indicated by the blue background, you can use the arrow key of the keyboard to move from one tag in the list to the next. And as we do so, you'll notice how the signals change because we're changing the vertical scale of the main display each time we select a different tag ID from our list box. So as we keep scrolling through, we see here that some signals are coming into where we have another set of horizontal signals being displayed. And if we zoom in, and in reviewing the data from all hydrophones, let's look at data from hydrophone 2. And once again, we can query to see that if these two sets of signals are coming from tag 6659 with a subcode of 19. So if we do a query, we can just do a section of the signal. And there indeed, the subcode histogram tells us that, yes, these signals fit within our subcode 19 range. So this is an indication where we have the correct scale set for tag 6659 and viewing these two transmissions as subcode 19. So these would be from signals coming from that specific tag. We can keep scrolling through and looking for other tags. Or go back to the one we were looking at. Another feature in MarkTags is being able to display a georeferenced scene. So under the scene option, say open. And if you open it and then select the map option, it displays along with the main display, the georeferenced map of this project site. And we can, using the thumb wheel of your mouse, scroll in and center the map to get a better view. And right-clicking, there's display options for setting the various sizes of the symbols. So for the hydrophones, let's make them a little larger. So here are 4 hydrophones. In fact, you can click inside the symbol and it'll tell you which hydrophone number. It's hydrophone 1. And so we can go back to our display, look at all hydrophones, and see that, again, this tag was observed at the end of the file. So let's take a look and see if it was detected in the next hour. Open up the next hourly file, 1900. And here we see the tag, as we did before in the previous hour, and it goes until 1924 approximately, where the tag was no longer detected from the hydrophones at this project site. Now, just viewing this information, let's look at each individual hydrophone, and let's zoom in. And let's see which hydrophone was the tag last seen on. So we can set our bookmark. As hydrophone 1, hydrophone 2, 3, and 4. So it looks like hydrophone 1 was the last to detect that tag. Let's switch our display options back to hydrophone. So we see here that hydrophone 1 was the last to observe that tag. So more than likely, even though we have not done any tag positioning, that's a pretty good indication that the tag that came down went through this channel rather than this one, since this was the last hydrophone to see it. If it would have been down this channel, hydrophone number 3 would have been the last to have seen it. And it wasn't here as far as our bookmark indicator. Then we can look at the next hourly file. And we see that the tag is no longer detected in the hydrophone array. So this concludes the introduction to the MarkTags software.